Okay, so now it's like the entirety of the rest of the presentation is so deep in learning about what is multispectral and how it's used in specific use cases. And I may have those like junior questions that maybe for me to have full understanding or to just kind of to catch up to speed. I might have those questions, but this is like all you. So Kyle, what is multispectral and how does it work?
Sure. So let's start from the left to the right, and we're just going to do photos to make it easier. So on the left-hand side, we have the entire electromagnetic spectrum. That's basically everything out there. It's the visible spectrum of light that we can see, colors, very small part of that electromagnetic spectrum, but when you zoom in, you can see it's typically between 400 and 700 nanometers. That's the distance, the band of light. Blue or purples being on the low end, reds being on the high end. When you get above that, that's into the near infrared. And then if you keep pushing, that's where you get into like thermal cameras. What we've noticed over the past decades of research is that within the visual bands of light, it is very hard to tell the difference between healthy and unhealthy vegetation. So between the blue and the green and the red bands of light, there's some differentiation, but it really takes the plant nearly dying, turning yellow, before we can actually see it with our naked eyes, that stress that's hitting the plant. But when we look at bands of light beyond what our eyes can see, beyond red into the near infrared, the differentiation between healthy and unhealthy just explodes. And so we're able to see when plants start stressing before the naked eye can even see it. And then what we're doing then is, can we make a management decision to save that yield potential that's out there? You can see on the right-hand side as well why we would need a multispectral camera. So on the bottom side of that graph, I apologize, it's a little bit small there, but you're seeing a 3-channel camera. 3-channel camera, just like on any smartphone that's out there, it's capturing red, blue, and green bands of light, and it's trying to capture all of those bands of light within those colored channels. So it's not being very accurate, but it's creating a very pretty picture. Multispectral, the other way. We're focusing on one band of light as accurate as possible. So if you look at what a multispectral camera is there, we are getting high reflectivity within those bands of light, and then it drops right back down. But we're very accurately picking out blue, well, red, green, near infrared, and red edge, rather than trying to understand the whole spectrum and being very messy at what band of light we're looking at. Next slide.
Kyle, one second. Before drones, were growers using multispectral cameras in another way as a traditional method, or was it using your eyes to see where you needed to address drought stress or insects or something like that?
Growers really weren't, researchers were, but a lot of that was, back in the 70s and 80s, they were putting up near infrared sensors, but that was on Landsat. So you're looking at terrible resolution, but it costs a lot to manufacture high resolution near infrared sensors. So it really had, the actual use on the farm hasn't taken off till probably the late 2000s with manned imagery, early 2000s, and then satellite data.
And then thus far, what have you seen as far as like adoption and efficiency or crop yield improvements by using drones? Is there any data that's out there that is more concrete of why and how, what is the benefit of using this technology?
That's what the next slides are going to be for. With ag, it is much more difficult, like the use case slides in entirety. Yeah. Ag is difficult because 50% of the time that I'm flying conventional crops and trying to do crop scouting, I don't learn anything. Like the problem areas of the field, I knew that's where the problem areas were because historically that's where they always are because of the soil type or whatever that is. But 50 or even 20 to 30% of the time, if we learn something, we probably can make a management decision that will pay off the drone 2, 3, 5, 10-fold. So it's not every time you go out there ROI that we're talking about with oil and gas and construction, but a lot of the values is can we find problems and fix them?
Gotcha. And is the multispectral data flown usually like mid-season, in the planting season, in the harvesting season? Like how long is the season that you would use multispectral data throughout the growing year?
Man, I shouldn't say it was one that Drone to Play had created, but they have a really good representation of when to fly throughout the entire growing season. So we're going to be flying now and just using the visual camera to do any sort of topography and elevation change. We might be doing some subsurface irrigation, or not subsurface, we're doing some subsurface drainage. And if we're going to be doing any sort of tile work in our area, we might need elevation maps. We're flying early to understand with corn and beans, soybeans, to understand emergence. We're also flying it before putting on any sort of fertilizer, so side dressing or top dressing. We're also flying 2 or 3 times throughout July and August, mainly July, to stay ahead of any sort of disease and understanding if and when we need to apply fungicide. So the biggest times to fly in Iowa for corn and soybeans specifically is going to be typically the 1st of April, getting topography stuff all the way towards harvest and getting drainage stuff after harvest even.
So maybe one thing we'll follow up on is trying to locate that drone deploy thing. And when we send out either answers to the Q&A or recording or something, we could try to attach that to it. So I'll try to remember that. So what are we looking at here?
Yeah, so we just talked about what a camera looks like when we're capturing bands of light very accurately, but only individual bands of light, like captured. We're not capturing all 3 within one image, we're capturing them individually. So each image comes back as a grayscale image, very accurate image, but we don't know really what we're looking at. It's just kind of gray, some parts are darker, some parts are lighter. You can see just a visual camera, but we'll take these individual bands and we will do a calculation on them to make, and if you want to go to the next slide, we'll do a calculation on these bands to make a map you may have seen before, a plant health map. So if you've ever heard of NDVI before, or a plant health map, it's usually based off of NDVI. All it is a calculation on the near infrared bands of light and the red bands of light. So here's a tomato plant. If you see the near infrared band image, the red band, we're subtracting the values, the reflectivity values, divided by the near infrared plus the red, a little bit confusing. But when you run it through, what will come back is a scale from -1 to 1. Typically 0 on that scale is no vegetation. Anything below that can be like water and different surfaces, but we're focusing on 0 to 1. The higher the number, the more plant biomass, the more vegetation is there. And so you can see on this tomato plant where the most vegetation is, where we're seeing the most dense. So we're taking the individual bands, converting them into a plant health map, but you don't have to worry about it.
So when you convert this, are you comparing plant to plant to know like where there are issues within your plot of land, or are you looking at the plant and comparing it to itself or a known species to let it know whether it's healthy or not?
Man, yeah, it all depends on what type of analysis you're doing. If you're doing trend analysis over time, you're comparing it to what that plant was a week ago within that plot. You could be comparing it to another plot for plot analysis to understand which plot is healthier. Yeah, it can be any sort of which way that you want.
Okay, and does Terra / Smart Farm / Pix4D or Drone Deploy help with that analysis?
Exactly. So we're teaching all of this, but you don't have to worry about it. We do this plant health analysis when you upload the imagery or when you load it into Terra and process it. All you have to do is hit a button and then it'll just turn on NDVI. But we're just trying to tell you the basics of what's happening. Exactly. Perfect. So there's a bunch of different, you can make up that calculation on these bands of light on however you want. The most common that we found is NDVI. That really correlates well to plant health. Whatever that reflectivity value is, if it's higher, it's usually a better plant. If it's lower, it's a worse plant or a stressing plant. But there are other indices that you can utilize depending on the time of the growing season. That gets pretty deep though. It might be hard to do with the webinar timeframe we have.
Perfect, but these are things to note, and these are also indices that are available through software, correct?
Through Terra, yep, or through Pix4D fields or whatever.